The next one that we are going to treat is electromeric effect. Electro what? Electromeric effect. What is an electromeric effect? See, this morning we are talking about what inductive effect, which is the shifting of the sigma bond electron into the element of higher electronegativity. Abi? But in this case, this one differs from the what? Inductive effect. Its own is what? This is a compound now. In this compound, we have how many bonds here? 2 bonds. The first bond here, this one is sigma bond. Sigma. The one up here, we call it what? Pi bond. Yeah. So in the inductive effect that we did, it has sigma bond alone. And its own is what? Shifting of this sigma bond electron toward the element of higher electronegativity from this one. You now use arrow to what? To indicate it. This inductive effect. But in case of what? Electromagnetic effect, it is just deal with what? The pi electron. The electromagnetic effect is what? Its own is deal with what? Pi what? Pi electron. This second bond. And the electromagnetic effect takes place on a double bond. In a multiple bonds. We can never have electromagnetic effect in a single bond compound. We always have it in what? In double bond compound, like alkene and carbonyl group. So the shifting of this pi electron to the one of the elements here that have higher electronegativity, shifting of the what? Of the pi electron here to the one of the what? Of the element is called what? Electromeric effect. But what make this what? Pi electron to shift to this B. So if it will now shift, you have what? A, B minus, here we will have plus. But what is the scenario that is happening to make what? This pi electron to shift to what? To B. If you could say, remember, from Newton's law of what? Of motion, the first law of inertia. He said that what? Every object continues to state at rest or in motion unless external force acted on it. There is a particular force that is what? Acted on this pi electron. What is the force? We have reagent here. We have what? The presence of this reagent here make this what? This pi electron to what? To shift to this B. You will now have this. If I remove this reagent back, this thing will go back to this structure. As a result of that, this electromagnetic effect is a temporary effect. And it is shifting of the pi electron to the one of the atoms that is share the double or multiple bond due to the presence of what? Of external reagents and its temporary effects. Simple. By definition. This is a what? Temporary effect which involve the complete transfer of share pi electron or pi bond electron to one of the atom joined by a multiple bond. Multiple is very essential. Bonds. That is what? Electromagnetic what? Effect. It's not complete. It is occur in the presence of external reagent. Say it, add it to it. It occur in the presence of reagents. Without reagents, this reaction cannot occur. Take, for example, if we have A and B bond together like this, now I said electrometric effect cannot take place in a single bond, in a multiple bond. So, if we have this, and here we have the arrow here, at this place we have what? The A what? Let me put it here. E plus. If this E plus, we call it what? The A what? The agent. This E plus we have here is a what? Is a reagent. The price of this reagent now shifts this what? Pi bond to come to the side. You can see that we use arrow to show that is what? The two electron in this pi bond move to what? To B. You will now have what? A plus and B minus. So if I remove this thing back, don't be surprised, the reagent back, this will come back to what? To this compound. That's why I said it's a temporary what? Effect. It's not permanent like inductive effect. Let me give more example on this. In case of what we have a T. A T is carbon H, 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 H. If I now put what? External reagent here, what will happen? This external reagent will shift this what? Pi electron on top of the what? Of this carbon. As a result of that, what are we going to have? We have C, H, 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 and what? H. If you have it in this form, this one will become positive, this one will become negative because it's one that is going to what? The pi electron. If the pi what? Electron. If I remove this thing back, it will what? It will still go back there. This is what? The good example of what will I call it? Electromeric effect. Let me add one more. In carbonic. Look at carbonic group of CO like this, and I put cyanide here. Good. This cyanide, yes, this cyanide serves as external what? Reagent that is coming to this side to what? To attack this side, and all of that, this pi will come to what? To oxygen, and we now have what? CHO, this. And here, this all will become minus. Here we have plus. This is also what? Another good example of what? Electromeric what? Electromeric effect. But what are the pictures of electromeric effect? Or let me call it what? What are the characteristics of electromeric effect? Let's read that too. Characteristics of what? Electromeric effect. See, the electromeric effect, the first unique is what? I said it before, is temporary effect. It is what? What? Temporary effect. And this same electromagnetic effect, I said it before, is also occur in multiple bonds. It only occur in multiple bonds. Look at this man again. It takes place in the presence of reagents. It takes place In presence of reagents. So that is all about what? Electromeric quartz effects. Temporary effects that involve the shifting of the what of the pi bond electron into the one of the atom due to the presence of what of external what reagents.